Alright, let's start. Basically, I will be running you through how to set up the machine, get you ready for the process, setting up the material, how to center the material, and get the needle. First of all, we have an air compressor that's going to be hooked up to the machine, right? So you can either take the extension cord and hook it up, right here. Just like that.
Next day is close enough, you do not need the extension.
Well, he's giving an example if it's too far. Yeah, just wait. So the air compressor will be compressing the air. We have what will be going into the air compressor right here. Just push it in and it'll just click. So remove it, pull this back, and it may be a bit startling, but it just pops out. After you have that done, of course, you need to plug in the machine right here. Do not plug in the machine before, do not turn on the machine. You have two switches here before plugging in the machine. Always plug in the machine. Plugging in the machine is one of the first steps you always do. So right here, just like that. We have the water cycler over here. This is for cooling down the machine. You turn it on right here. And if you look up here, pretty nasty water, but this will be what will be cooling down the machine. So you want to make sure that water is actually flowing, right? If it's not, then what you have to do is you're going to have to move the machine around a bit to make sure it's actually getting water flowing, right? So
can you show them the water flowing? The other hose.
Yeah. See, right now, doesn't look like there's any water flowing, right? Through this hose right here, if you can look closely, nothing's flowing through it. So what you have to do is you have to move the machine around.
Next, there's another hose in the bucket.
That's what I showed them.
Okay, there's no
Be
water.
patient. And I'll start flowing water. I don't think there's water, no.
There's another hose here. Okay? Oh. You can lift it up. If there's water flowing, then it's ready to go.
Well, once you have that done and you turn on the machine, if you look back there, there's a switch. For those who can't see, all the way back there, there's a switch you turn on. After you have that done, what you can do next is you turn on these two switches right here, okay? This is to turn on the machine, the actual spindle and the actual movement of the thing. This is what you'll be running the machine with. Next gen tech, I know. So you power it on, switch right here. Once you have it powered on, again, you turn on the machine here as well. Log in using the guest. Right there. Here you go. Once you have it up here, you open up the Mach 3 mill. The Mach 3 mill is a program you'll be using to run everything here. So if everybody can get into somewhere where they can see the screen right here, this is basically the control. Of course, a lot of this stuff is for when you're actually running the machine. Emergency stop, click that, everything stops. Emergency, here's where you load in the G-code, right? And close the G-code. G-code is what you'll be actually be using to run the code. Once you have all of this, right, you open the file and you open the actual code. So for today, we'll be using this code. And if you can see here on this black area over here, you can actually see a diagram of the piece you're actually going to be cutting. And you can see some of its path in the red lines.
Alright, nice.
So,
Okay, next. Let me continue now. I'll go into more in-depth right now. So Juan, do you want to put the camera right in front of the thing? Okay. So make sure you all the basic setup, right? The compressor, turn it on the water cooler, pump, plug in the machine, turn this on, turn on the PC, launch the Mark III using the gas locking account. So this screen will pop up, and this is the basic startup condition of the machine, right? So what this program is doing right now is controlling the left X, Y, and Z of this machine, right? Let's just to show you right now. You can see that I can use the X, is these directions. You see this X, Y, and Z. So if I go X, it moves left and right. Okay, Y is going up. Y is this direction and going back this way. Z is going up and down. Okay, now be very, very careful. You do not want to extend the machine all the way and this start hitting this guy, or the other way, or even this. You do not want to raise it too high that it start hitting this. The moment you hit this, it has a fail switch. It will stop the machine. You cannot control it anymore. Okay. For example, if I'm going to keep hitting it, not watching where it go, and it stop. It doesn't matter. So you want to be very careful not to hit it, because if you hit it, you're going to start destroying all this step motor, right? So it's very, very fine step motor. So if you hit it and you keep going, it's going to grind the gear. Make sense? So now you can also use keyboard. X, Y, Z is page up and page down. Okay, make sense? Okay, now in this menu here, you can see you can load G code. G code is what you finally get that you want to mill the parts. You can close the G code. You can load a new one. For example, this is the one that Toby just mailed just last week. Okay, or you can rewind the program. You can even start the Spindle. You can stop it. Let's say a program is running, something went wrong. Okay, as Max said, you can either click the E stop. Once you click E stop, you want to restart it again, you gotta click it to make sure it's green again before you start. Or let's say the machine is running and then something really, really horrible. If you're not feeling, you can also press this to stop everything. There's the emergency stop button here. Okay, once it stop, you probably have to unplug. No,
I got twisted.
you gotta there you go. Okay. Again, if you press stop, you gotta turn this to unlock it again. Make sense? Questions? Now, all this is, again, the G code is all just geometry. X, Y, Z, and spindle speed. And then the feed rate, right? All this is what the G code is telling the machine to do. What else? Basic stuff. Okay, Max, do you want to show them? Put on that.
So, to put on the spindle, we have two little wrenches. Over here. What these do is they'll fit on
It's in here.
this. Will screw onto up here, right here. And what you can do is these two wrenches, if you can see it down here, there's a slot for the small wrench. Slot in. And for the bigger wrench, this is for this little part right here. And you turn to tighten it. Once you have it tight, because you can't have it loose while it's spinning really, really fast, otherwise something bad will happen. So once you have it relatively close by hand, you can go and switch to these two wrenches and just tighten. These two wrenches are in this box right here with a lot of other things which you'll be using later on, but that's basically it for that. Once you have the spindle set up, then you move on to your material. So, for a second, there's a multitude of different material that we can be using. For today, we're just going to be using polymer for this. And what you want to do while setting this up is you want to use these black pieces. Do you know where they are?
On top.
These black pieces. What these black pieces will do is they're going to go underneath this thing. Because this spindle will be going through this entire material. And if you don't have something underneath to buffer it, it'll be just drilling through the actual machine. As you can see in a couple of places, you can see the spindle drilled through the machine. And that is not good. So once you have it set up, you lay it under. And these little things right here, this is what you're going to be using to secure the actual piece and make sure it doesn't wiggle, it doesn't move while the spindle is cutting through it. You see these square little things at the bottom? This enters through all the way at the back, and you slide it all the way in. And you have 4 of these to secure it at 4 positions. One at a time. So as you can see on the CNC machine, there are little lines of slots where you can slide in the actual securers. So once you have your material, you take them out. If these are still in the machine, you can take them out and position them however you want in order to actually secure this well. So you lay this on the black material, okay? And once you have it under the black material, use these securers to get it actually secure. And you can move it around, position around a bit, so you can actually secure this well. As you can just see, I'm just moving around the pieces to get them positioned over the material so they can secure it down. Sometimes you'll just have to set it up and look around because as you can see here, right, this little piece right here, it's not going to be able to reach the material. So what I can do is I can take this out and instead put it on this slot.
Also depends on where you want to cut, right?
Yeah.
If you do not cut that far back, then you do not get it.
Yeah. So of course, you can always take it out and move it back in. And so if you can see back here now.
Max, where do you want to
secure
cut?
this general area.
Okay, then you should secure that area.
Yes.
Is it better to like, right, you know, there's obviously parts that are sticking out of the thing,
Sticking out is fine as long as you do not cut over,
right?
right? Max will show you that.
When you are setting up these slots, there's gonna be another screw down here that's gonna help push it up against the machine. You don't want to have that piece going into the slot.
Slide it under.
Yes. And you have these metal pieces to slide under. And we do have these little metal pieces over here that will slide under this screw so that it doesn't hurt the machine and it can go over these little slots. Once you have all that,
Max, you also, it's not even, right, Max?
yeah.
Where do you want to cut? You're gonna cut over here. So you should secure 1, 2, 3, 4. That's it. You do not care about here. Right? You're cutting over here. So do move this over here. No, just move that over there. Over here.
I need to get this one out.
Yes.
And we have a wrench here that will usually be in that box I showed you before, right there. And this wrench is what actually tightens all of this, right? And while you're setting up, as I said before, you really want to make sure that the relative dimensions of the material you're cutting, the piece can actually fit on it, and it's positioned well enough that it will cut down. Once you have it tightened, you have to calibrate the positioning because, of course, if you look up there, that cross section, these two little lines, determine where the machine thinks it is and relative position over the material. It's always going to be wrong once you set it up. What you're going to have to do is you're going to actually have to calibrate it.
All right. So as you can see, right, you're gonna spend a lot of time setting up your material. You're gonna make mistake. You're gonna say, hey, I put all the plate here. I cannot clamp it. What am I gonna do? So you may have to move things around. So you're gonna spend probably 20 minutes each time just to set up the material, right? There's the usual process. So once you set it up, everything is tightened already. Now there's, okay, when you, okay, now you're ready to cut. So how do you know the machine is going to cut in the location you want it to cut? Is the machine going to cut outside the material, or in the center of the material, or right at where you want to cut? So this is where the XYZ calibration come into play now. Okay, what you normally do, if you can go to here, once you loaded this up, when you cam your parts, if you put everything in the center, you click 0, X, 0, Y, it's going to move this cursor to the center of the part. Assuming there is a rectangular raw material enclosing the part, this is the center of that rectangular. Okay? So, first thing you have to do is to find out what is the length of the part, the X and Y dimension of the part. If you know from your CAM, from your CAD design, great. If not, what you have to do, you're going to start moving this. As you move this, you can see this cursor keep moving with it. Right? Remember, every time you move, make sure it doesn't hit on the wall. So you can keep moving. All the way to the edge of this part. As you move, keep an eye on that as well. Always keep an eye on here and here. Okay? You can use the scroll button to zoom in. Hold the middle screw button, the right mouse to pan. Okay? So you can zoom in more to see that's right about where the Y is. Now, what you normally have to do is, now you need to know, this is from the center of the part. From the center of the part, I know the X is 112 millimeters, so 12.2 centimeters, 11.2 centimeters. So that means the length of the part is 22.4 centimeter, right? Do the same thing on the Y. Keep moving the Y. Keep moving the Y button until it reaches the end of the part. Approximately. There you go. So I know this part is 22.4 centimeter long and 5.6 centimeter in the Y directions. Okay. What you have to do now, open up the notepad. Where's notepad? Okay. Record these two numbers. 112.85. Y equal to 28.1. Now, why are these two numbers important? Now that you know where the X, Y at the corner of the part, whether it's the left top, right top, bottom, left, bottom right, or bottom left, doesn't matter. You just change the sign. Okay? Now, with this information, now I can start playing this part and say, hey, I want the machine to start cutting from the edge. Right? If I'm going to draw it out, let's say I want the machine to cut. Let's say I want the machine to cut in this box. Something like that. Okay? Let's say this is where I want the machine to cut. This is the box that I want it to. Okay? And I say, hey, I want the machine to start cutting from here. I want to line up this corner here to be this corner. Remember, right? There's a rectangular box that the part will also go in. So what I have to do now, I'm going to move this machine, move the end mill to that corner. Okay. Once I position that end mill to that corner, now I can go into here, change the X and Y of the machine. From what I record before, I know the X is 112.85. So I can go in here, you can see the color change to a lighter green color, put in 112.85. 112.85. Now, before I click enter, you can see that once I click enter, that cursor is going to move to there. Same thing, Y, I know Y needs to be 28.1. 28.1, once I click enter, you can see the cursor now move to there. Make sense? So what it means is that is the position that show here, right? This cursor here, this cross cursor is showing exactly where the position of the machine is right now. Once I calibrate X and Y, now I'm going to start moving around and see if my parts is going to cut within that box. There you go. Sometime, let's say there's a cut here. Once I move here and the bit does not have material to cut, that means your position is wrong. So then you have to start moving down, right? In this case here, you get a perfect square pieces. Sometimes you have tiny pieces that you don't want to scrap, you want to reuse it as much as possible. So once you position it, make sure move around, make sure the part is still within the rectangular boxes that you wanted to cut. Okay, but it's not always rectangular. Let's say at this corner here, let's say there's no material here, but my part doesn't need to go there. Let's say my part looks something like that. That is my part. So it doesn't have to have material here. That's fine, right? If you go, let's say this material here is empty out, and if you keep moving here, there's no material, it's fine. But if you look in the screen and say, hey, there's nothing to be cut there, why do I care? Make sense? So this is how you calibrate X and Y. Okay? Again, when you cam it, doesn't really matter if it's center or not. You got to find the X, Y of the rectangular box that you're going to cut. Record it, move the end mill to that position that you want that new X and Y be, and start typing in the new X and Y. Okay? So there's X, Y calibration. Z calibration. We have this part. What this part does, you're going to plug this here into here. What this does is that, and then you move up the Z, put it here, you clamp this guy to the bit. Okay? And sometimes when you're doing soft material, this piece is not centered, so it's not flat, so you need to push it down yourself. Once you push it down, you're going to click on this Auto 20. You click on it, and the machine is going to find out. Okay? What this does is this. The thickness of this guy is 19.45 as it's enter here. So you do not have to muck around with it. Okay? We measure this thickness 19.45 millimeters. What it does is that when you plug this in, go to here. When you click on this click on this Auto 20 button, the machine is slowly going down until the bit make a contact on this. Okay? When the bit make a contact on this, it closes the circuit and it tells the machine to stop. Very simple. Okay? So press it down, click on this guy. That's it. That's your. What this calibrate is that is it will calibrate this guy to this surface. This will be the Z, 0. You can see, right? If I start moving down, you can see that right here, that will be the 0. Make sense? So the machine will automatically find out the 0 of this material is right on this surface. That is your X and Y and Z calibrations.
So it's not perfectly 0, right? It's a 0.0 point. Is that?
Well,
is
this is not.
Mhm.
Right? This material is soft and we did not clamp it quite well here.
Okay, I see.
Right? Okay? Any questions? X, Y, Z calibrations. Very, very important. Okay? If you do not calibrate well, few things may happen. You may cut outside the material, or you may cut too shallow, so material did not cut off, or you may cut too deep that you may even cut into this bed. So XYZ calibration is important. Okay, again, these pieces here, very simple. Plug this guy into this probe, put it over here, connect this to here, plug this into here, and press this button. That's it. Any questions? All right. Now, once you have it, you're ready to cut. Few more things you have to do. You see this water bottle? Okay. Make sure this water bottle is filled. If not, there's a hose here. You can open it up and just fill it up. Okay. Make sure this is submerged into water. What this does, it is to spray water mist. Right? You see something like that, and point it to the bit here. Right? This is to cool the material. Okay. For aluminum, you probably need a lot more water. For polycarb, you do not need that much water. So, and also once in a while, you gotta keep monitoring there's water coming out. If not, if you feel like the bit is too hot and the cut is not, it's melted, or when you cut aluminum, it doesn't cut smooth, you might want to increase the water. Okay? So there are two buttons here.
The tool which should use.
Normally we only have this 1/8 end mill. We do not have.
Regardless of the material,
Oh, for the material, 1/8 is good enough.
even if it's aluminum.
Even aluminum.
Okay.
Yeah. Right. We have 1/8, and we have something smaller. As I recommend in the camp, try not to use it. This is really hard to use. It breaks very easily. Right. I also have something real big, but they don't use it. Your design is not that big,
Yeah.
right?
So these are all end mills, right?
End mill, right? In most situations, you just need 1/8. That's it,
Okay.
right? I have something really, really big, but those are for huge cut. They're never going to use it.
Yeah.
Okay, back to this. So there are two buttons here, right? The big hose is where the air coming in from the compressor. This is the air. This button here, one, if you want to come over here. This is to turn on the air. Okay. The other button is the water. Okay. So turn on the air first, and turn on the water. You can see there's a lot of water here. So you're going to lower the water a little bit to something just like that. Make a simple mist like that. Okay? Then you're ready to cut. Point this guy to here, to this end mill. Now, very important. Sometimes depends on your material. You may have all these around here. So you want to watch out that all this clamp here doesn't hit and relocate this guy. Okay, very important. You can put it far up high here. Depends on your clamping system. You got to look around, right? Unless you got to keep an eye on it. Otherwise, if you hit it, the mist move away and you can start burning up. Okay, and then this is it, right? Now, before you start, it's always good to rewind first. As the program, we go to the beginning. And then now you can start cutting. Okay, I'm going to change the Z right now to be up higher. Okay? I'm going to tell the machine, this is a 0 right now. Up high more. Okay? I'm going to pick it. I'm going to have the machine to cut in the air for you to show how this does, how the machine moves, and how no exceptions. Okay, no exception. Second thing, you may want to bring your earplug, right? Because it's really noisy. The machine is noisy, the compressor is noisy. Sometimes you will have homework to do because you don't want to sit here for 2 hours, just look at the machine, right? You can do homework and keep an eye on it. So bring your earplug, put on goggle all the time. Second thing, long sleeve. Do not have long sleeve and get close to this. Very, very important, right? If you have a piece of napkin, I have cases that I'm trying to wipe the water, I get cool close, this got straight in and get into thousands of pieces right off the bat, immediately. Because this thing is going to turn 21,000 rounds per minute. Really, really fast. So if you want to get close to it, make sure you do not have sleeve, no glove, okay? Very, very careful, right? This is important. Now, one last thing. You can see Max got cut just now. Because it has this bit here and it's trying to move things around, right? It's very easy because you want to start shifting it and move your hand around and you're going to get cut by this guy, okay? It's a good idea to somehow clamp everything down first before you put this bit on, okay? Otherwise, you can get cut easily. I got cut many times. Okay?
Would it be also good to just shut off the system while you're...
It'd be good to, no. Shutting off is not easy because you want to move around and see where it is, okay?
Right.
But you got to be careful that you're not...
Or even just mounting it, like just getting it mounted.
You still need to move and see where it is, right? Okay, again, try not to have this in first, climb everything, and then you just eyeball it, make sure that X, Y, Z is okay. Then you can put this on, okay? One more thing. After you finish cutting, right? Especially for aluminum. Aluminum, once it cut, it's become very, very tiny pieces. Very, very tiny, right? You do not want to touch it. Once you touch it, it will stick in your finger, it will last days. Take days for it to come out, okay? So, be very, very careful with aluminum, the debris coming out. Try not to touch it. At the end of the cut, you want to do clean up. Of course, we have a vacuum cleaner here that you can clean out. You may want to get a kitchen glove that you can just put it on. So those plastic tiny gloves, put it on, clean up, and throw the glove away. Okay. What else? Okay. Let's. Now this is just a demo. I'm not gonna cut it. I have changed the Z to tell the machine this is the 0 position. Okay. What you have to do right now is everybody. And you have this piece here, okay? Normally, I just sit here, right? I'm not gonna sit over there. There's a mini van over there. I sit over here, I just put these two on, and put this shield on. Just extra precautions, right? So you get anything flung to your face, which very seldom, you get extra precautions, right? You have goggle on, you have. So that's what I do, right? So once everything is set up, make sure this power is on. Make sure this VFD, variable frequency driver, I think. Variable frequency driver is turned on. Rewind the code, and you can start. Okay, back. Okay, so I'm gonna start test run it. When the program start running, a few things to notice. Number one, you can see this cursor keep moving to where the end mill is. Number two, you can also see all this line advance. Remember, G code is just line by line command. Go X, Y, Z, how fast you turn to make a curve. Just line by line. Very simple syntax. So as the program runs, the cursor will keep moving, and then the program will keep showing this white line here to say, I'm running this line right now. I'm running next line, next line. Now, if you want to see the line number, for example, sometime you may want to edit the G code yourself, right? So what you have to do, open up that G code. Where is the G code? Okay. For example, this is the G code that we are running right now. You can see line number here. So if you go back to this machine here, you can double click on this screen here. It also starts showing the line number, right? You can double click it where you're running. After you run, before you run, it doesn't really matter. So again, always start rewinding to the beginning. And then now you can start. You can see the machine starts spinning. When it spins, so the speed right now is 11,000 round per minute. You can see that it starts cutting this hole right now at this corner. Right? Of course, it's not cutting it because I fake it to cut in the air right now. Right? So you can start seeing that it starts cutting layer by layer. And you also keep an eye on this Z. You can, with this Z, you know how far down the machine has cut. Because from your CAD file, if you know your material is about 4 millimeter, you know that when you get to 4 or 4.5 is the last cut. So I have some rough idea where the machine is, which layer is cutting, which part is cutting. Is it cutting the hole right now? Is it cutting a slot? Is it cutting a line? Have some rough idea, right? From this line number, you can see it's operating line 43 right now.
But we can scroll down to see what the last line number is, right? That
Say again?
You can scroll down to see the last line number,
Yes.
so you can get an idea.
You can scroll down,
Yeah, yeah.
right? This is probably the last part. Once it's done, you move on to the next feature, which is another hole. If you want to you can zoom into here. Now, sometimes you find the feed rate is too fast, right? You can feel the machine is cutting way too fast. You can click on this, going down to 90%. You can slow down the machine feed rate, right? You cannot slow down the spindle rate, but you can slow down how fast it moves. Okay? If you reset, it go back to 100%. If it, sometimes you say, hey, I can go faster, you can keep increasing it. Okay? When you're done, if you want to go back to default, you click reset. It go back to 100%. 100% as in what you set in your cam file. Okay? I'll make it move really fast right now.
What's the highest you can go?
I don't know. This is just demo. I wanted to go faster.
Yeah.
Yes. Okay, let's talk about that. Now, sometimes the bit broke. What do you do? Click on pause. Okay. Once you pause, you can stop the spindle. You can go change your bit, and you can recalibrate your Z. Now, it's not that simple. If the bit broke where it's about to start the next feature to be cut, it's easy. If the bit broke in the middle of cutting it, or you finished cutting already, right? Sometimes you're chatting with your friend, you do not know a break, and then you cut for 5 minutes. How do you resume? Right? What you have to resume, how you resume is you have to manually create your own G code to start where you want the machine to start. Okay? Let's say you do not have to do anything. Let's say I want to go for a bathroom break. I'm just going to freeze hold, not stop, freeze hold. And stop the spinner, go do your stuff. When you come back, just turn on the spindle again, let it settle, and then if you do not move anything, you can just click start and continue on. One last hold to cut. And then you can start cutting the perimeter. Because this part only have 5 holes and the perimeter, that's it. Now you start cutting the perimeter. You can see the perimeter cut start from here. You start moving. Okay, I'm going to stop here. Okay, let's go a few more things you may have to do. Okay, let's say I stop everything. To answer your question, let's say the bit broke. Right? I change the bit, recalibrate my Z. I want the machine to restart from a particular feature, not the beginning of the file. What do I do? Now, if you click on this, you can keep scrolling and see I'm gonna rewind it first. Click on this screen and keep scrolling. You can see that white dot. You know that line is to cut that hole. You can keep scrolling. You can see that white dot will move. Okay, now you see this line here. This command line is where the machine is going from that point to that point. Okay, so with this screen here, you can skip through and see the feature where the starting point is. Once you know the starting point and the feature that you want to resume from, you can now go start editing your G-code manually. Make sense? So you can start deleting. Say there's 6 holes at the beginning, right? Let's say I finished cutting all the holes. I just want to cut the perimeter. I keep scrolling down until I see the perimeter cutting happening. Oh, I passed it. Okay. Keep scrolling back. You can see that this is where it moved from here to there. So now I know this line. This G41, D22, right? This is the line that I want my new program to be. Let's say I go save this file, save as perimeter. Okay. Now then I need to go find out this line. Okay. This line number 351 may not match this exactly because the program will skip all the blank line, empty line. So this should be around 350, right? If you go to line 350,
Or could you just search for that?
you can search for that too, but you gotta be careful, right? It should be in the vicinity of this line,
Right.
right? You may have multiple of this exact same thing. So around here, you can see that around 350, there you go, there is the line. G41, 222, this line, right? If you read this G code, you can see that this, remember, this IJ is making curve cut or circle. So I know this IJ got to be this hole because that's the last hole. So you can see this IJ saying here, then you ask the machine, go to Z 4.5. That means it's raising up the Z. Right? The next line, you go to Z5, another half a millimeter, and then you start moving to a different X and Y coordinate. You go to X0, Y28. So I know that is where that guy is. Okay, so what you have to do, you can delete everything all the way to the top until the first G00. Okay, G00 is where the program starts. I delete everything, now I have my new program. As simple as that, right? So remember, original program has 1, 2, 3, 4, 5 holes. If I close this, if I load my new code, perimeter, there's nothing else, only perimeter, right? So again, you're gonna come up to this a lot. As I say in the tutorial last week, things break, bit broken, thing doesn't cut well. You don't want to start the whole 2 hours of cut. You want to find out where you want to start again and modify the code, right? The way to find it is click on this, keep scrolling down, and find out where you want it to be. And then find that line in your G code and modify yourself. Okay? It may sound complicated, but you need to spend a bit of time, modify your code, load the code in here and see if it looks right, things like that, right? If you're not sure, rewind it, do a fake cut, set the Z up high, and run the code and see it looks right. Okay? So now it looks right, right? Sometimes your modification does not look right, the machine will not even cut, or the G-code loading, this screen will not show up, so you know something is wrong. Okay? Now, Important thing. If you have to modify G code yourself, do not touch X and Y. The moment you touch X and Y, you lost everything. Okay? Do not click 0x, 0y. If you click it, you lost everything. You lost your coordinate. Okay? You can 0z, z is fine. Z is up, just up and down. You can 0z, you can mark around with z, but do not change X and Y. Make sense? Okay, and also remember, every time you start program, load your code, rewind it, try reset the Z, reset the spindle. Okay? The reason you want to reset is that you may have multiple pieces of code. From the previous code, you may have set the feed rate to 150%. You close the Z code, you load the new Z code, it is still at 140%, right? So you always want to reset the feed rate, reset the spindle rate to 100% of what your G code instruct the machine to do, okay? Just simple, regular practice, okay? Sometimes you can see that there's a status that says USB disconnect. Not connected. What you have to do, raise your hand to the back here, this USB port, unplug it, plug it back in. Okay? And you say USB connected. Right? If you see that USB not connected, unconnected messages, just go reach behind, plug, unplug. That's it. What else? Once you plug and unplug, this E-stop is blinking, so you need to click on the E-stop to make it green. What else do you need to do? There are other stuff that how to control the machine by stepping slowly. Let's not get into that. You seldom has to do that. What else?
Did we go over changing the drill bit during the feature?
Say again?
Did we go over changing the drill bit during when it breaks
Oh.
during the feature?
Changing the different drill bit or replacing the drill bit?
Replacing the drill bit.
Yeah, pretty much what it says just now, right? If the bit's broken, you just stop the program. Do not change X and Y.
Do you stop it or do you pause it?
Yeah, you pause it. You pause it, right? If you want to just change the drill bit, that's it. Just change drill bit, not changing where the feature is to be cut. You just pause it. Stop the spindle. Okay? And then you can go change it. Okay? Again, these two pieces.
I mean, if you do an E-stop, you can still start it up again if you just set it to the right position on the G code.
One second. What's the questions?
If you do an E-stop, you can still set it to the right position if you put it in the right G code,
Okay.
right? What's the difference between pause and E-stop? Like what?
Once you stop, you have to modify your G code
Okay.
to strip off all the previous feature.
Okay. But
Because
the
once you
pause-
stop,
Yeah,
you can only start running from the beginning.
from the beginning. Okay,
I don't think it has a feature that says start running from that line.
I see.
Load, close, rewind. Yeah, I
So,
don't think I have that
so
feature.
if a bit breaks and you want to restart it, do a pause, not
Do a pause.
not an E-stop. Okay.
Do a pause. Okay? If you do E-stop, then you gotta start stripping off,
Yeah, you gotta
modify your G code.
modify the G code, right?
Right?
Yep.
What else?
What if the hole is smaller than that bit?
As I say in the camp, don't do that. Remember, right? In the camp, I have 3 bits, right? 1.8, 1.6 millimeter, the other one is 2.99. Okay? 2.99 is not a real bit, it's a fake bit, right? 2.99 is created because Michael say, if you just use that bit, if you use 1.8, the cam would not work. It will not cut because that hole is smaller than 3.17. Right? So that fake bit 2.99 It's the same bit. It just plunged through. Use 2.99, the cam would recognize it and say you can use that bit. But again, now your program has 2 bits now. Remember last in the cam file, I said in the cam lesson that if you have 2 bits, you need to have 2 G code. Right? You can suppress the feature, suppress everything using the big bit. A small code only drill the small hole, and then change the load the code. I may have some programs here. Let me check. Okay, if you look at this G code, right? This is one of the carousel plate. Okay, Michael has some tiny hole that I cannot cut with a regular bit. So I created 2 G code. I call step 1 and step 2. Step 1 is everything that can be cut with that 3.17. Step 2 is step 2. Step 1. Okay. The other doesn't matter step 1, step 2. You have 2 G code. One is just a small hole. Right? If you can use 2.99, just use the same bit. Good enough, great. If not, if you must use that 1.6 millimeter, you can use it too. But as I say, it's really, really hard to cut. It breaks all the time. It's really tiny. Okay? You can use it for polycarb, easy. But for aluminum, not easy to use. Not very easy to use. Okay?
So this is used for milling or for drilling?
It's the same, right? You can use it to drill, or you can use it for the milling too as well. Same thing. It's a flat nose end mill.
If it's making small drill, would you just rather just use a drill press if it's too small?
Where's the positions?
Hmm.
Right? You do not know the positions,
Or
right?
you mark it?
Huh? Well, when they have, let's say, this is their piece, right? Let's say there's some tiny hole here. You cut everything. You do not know their positions, right? Once you take it out of the bag, go to the drill press, you do not know where the location is.
Or maybe even just mark like just pilot holes.
Okay, then you're gonna have to change your CAD file to make a small, shallow drill,
All right.
right? The things you have to do in the CAD, if you must do that. Make sense? You gotta get the position,
Right.
then you can go to the drill press. Without the position marking, with the shallow cut, you lost everything. You lost all your coordinates.
How did you create that bend on the side plate?
This one,
Yeah.
burn,
Oh.
melt, torch it. You press it down with 2 big metal pieces, melt it, and bend it. Right? Same thing on this guy.
Is this polymer?
This is polycarb.
Okay.
This which year is it? Anybody remember?
Ultimate cool.
Yeah. Last year, right? The year
2 years.
before?
Yeah.
Yeah.
Does that method
For example, look at this, right? This one is, I think I set it up and go buy grocery at once. End up, it's getting too hot, right? I spin too fast, not enough water. The plastic melt. Once it melt, it create a big clump onto the end mill and keep cutting it and start scraping it. That's why I say somebody got to be here. You cannot set it up and go because things always goes wrong. You can bring your homework here because sometimes you may have to spend 2 hours, 3 hours here, right? You're gonna spend 15 minutes to set up, and you can start doing your homework, reading your storybook, and just keep an eye on that, back and forth. But not a good idea to have no people here because things always goes wrong. Bits broken, not enough water, or sometimes the water got stuck. Then you have to increase the water. So you got to have somebody presence here.
So if you're machining aluminum block, how do you secure it? Like if the block is 2 by 2 by.
Say again?
If you are machining an aluminum block
Uh-huh.
that is like high, how do you secure it to the?
Oh, they don't. They
use-
don't. They always
everything
use
is these thin.
these are the material they always use, right? Either the what was 1/8? I think it's 1/8, or something thicker. Right?
But they don't.
They do not use the block.
I think that there are like vice grips that you can get.
I have a wise too.
Yeah.
But the problem is that this cannot reach that far high.
Yeah.
Okay? There are ways you can do it.
Right.
There are ways you can do it.
So
Just
just
have
mostly this is material.
for them, for FTC, these are the material.
Okay.
Right? They can use really thin one to as thick as this guy. This is the thickest one that we ever used. Where do we use this before?
The turret.
The turret, 2 years ago, right?
Yeah.
Right?
What's the thickness of that?
Oh, this
360.
Fourth, I think.
I don't know. Yeah. This is the thickest that we cut.
What is like the RPM for that?
2100. Aluminum's 21. Polycarb 1100.
What's the?
Those are the two in the cam, right?
Yeah.
I got two types, 2100 and 1100. Okay. Now, we have two type of material. 6061. I don't think you can see 6061 in this piece.
This one has a
Yeah.
66.
6061 is the material that you want to use. It's really easy to cut. Last year we bought some cheap one. Okay, you can still cut, but it's a lot harder to cut. Okay, 6061 normally come with all these red marking. Okay. If you must use the one without the red one, you can still cut. We cut a lot last year because we bought it. We just have to finish using it. Okay. If you have to buy new one, always buy 6061. See 6061 over here. Those are the material that you want to use. Strong enough for FTC and easy to cut. Easier to cut, not easy. Okay. You can also cut wood as well. I think last year you can have some prototype. Is it last year? No, 2 years ago. You can make a prototype using wood. Right? Prototype wood is great, really fast to cut. You make a mistake, you can recut it really, really fast.
What's the RPM for that?
I have no idea. I forgot. You're gonna have to play with it. You can lower it. It doesn't have to be fast. What else? Okay, once you have everything done, clean up. You're gonna have a lot of water, right? You can use this, plug this in here, clean up all the water, just clean up everything, right? Yeah, sweep the floor because the floor, this area here is gonna be, it's not that messy. It's not that. It's just pretty much that area. Okay? You're gonna have a lot of debris coming out. And once everything is done, power down. Reverse it. Power down these two guys. Unplug this guy. Turn off the water pump. Shut down the machine. Now, you guys probably do not know how to use Windows 7.
No.
Were you guys born Windows 7? So just go down here, just click shut down. That's it. This computer is really, really old. Really, really old.
So it's hard to define.
Well, it works.
Unfortunately, when I bought this, I did not know the software they give me is only on Windows 7 or XP. Right? That you can buy new software too.
Microsoft Word 2010.
Oh yeah. Best software ever.
I was born old back then.
It has self-correct feature. It means you have to correct your own grammar.
Wow.
Okay. And also I'm trying to set up a lighting system here. So sometimes this is not the final setup. I'm still buying a LED driver. Okay. Instead of light here, I'm trying to set up a light over here. Because you always want to know, get some lighting here. I'm trying to set it up. So Max just 3D print this guy. I'm gonna hook it up.
What is that switch for?
Turn off and off this guy.
Oh, okay.
Okay. Just bought some LED light. Just like, how much does it cost? Like 20 cents each. Really cheap. Okay, any more questions? Now, at the beginning, you may feel it may feel daunting, a lot of setup, right? You got a big machine running around, you do not know what. Yeah, but do it slow, right? If you do not know, raise up the Z and see where you can, get a good feeling about it. You may spend more time, but this way you start learning.
Did you want people to be here in pairs?
Not necessarily. Not necessarily. Like I say, depends on how many cuts they have. Right? Last year, Michael kept churning out part every week. You probably have to spend 5-6 hours of cutting. A lot of time, right? 5-6 hours is okay, but a lot of time, the MU meeting is on Friday. The MU guy is gonna have the design done on Sunday. They want the parts to be done during school day. Right? So there's always a challenge. Right? That's why I say, have multiple people, you can split up the workload. Right? Having one guy here 6 hours, you have like 4 AP, it's gonna be crazy. Right? Once you split up, hey, you cut part 1, I cut part 2, part 3. Each guy spend 2 hours in school day, it's probably okay. Right? Or you may want to change your design schedule, have everything designed done on Friday. People can start cutting on Saturday, Sunday for next Friday build. It may not work out well. You have to think about it.
What's the longest cuts, like time-wise?
Oh, longest cut.
How long?
The piece that you have on the side don't have so many pockets. Okay, used to be like 3 years ago. There's a weight limit on the robot, like 42 pounds or 40 pounds, right? How much? Something like that. There's a weight limit. If you have a weight limit, yes, you want to cut as much pocket as possible because you don't want to add weight. Okay, that's one reason, you reduce weight. Second reason of having a lot of pocket is that you want to be able to access what's inside, behind it, right? But every cut takes time. Make sense? So you got to think about it.
How long did that take?
The side plate that we have last year, probably like 2 hours.
Oh,
Because
Okay,
it has a
that's
lot,
not-
it has a lot of hole and
Right.
a lot of pocket. 2 hours per piece,
right,
left side, right side.
right. That's not, I mean, like we have like 3D printing things that take like 14
Oh, 3D
hours.
printing is a lot slower.
Yeah.
A lot slower.
Yeah.
A lot
So I was
slower.
worried like if it's like cutting,
But 3D printing is easy because
Yeah,
you can set up,
you can
go
set up and
sleep,
go,
and
yeah,
you
yeah,
don't have
yeah.
to worry. If it
Right.
fails, you set up again,
yeah.
right? But CNC is tough because you have to be here. You cannot go sleep. Right?
And the X and Y setup, and you also, the X and Y setup is also harder.
That's right. That's right.
Does the software tell you the expected time?
No,
Does not.
no. It tells you the run time, but it doesn't tell you the expected time.
So the runtime is.
It tells you how much, how long it has to
Maybe you
elapse.
can eyeball.
It tells you the
Since you
elapsed time.
Yeah,
Oh, since it's started.
probably after you do a few, you'll get a gauge of how many,
Yeah.
like,
But it's
there's
not
like
like
300, 300 G code lines. probably take 2 hours or I
Depends on the
don't know.
material.
On the material and your
But
feed
it's not
rate.
like 3D where
Not really the
Yeah.
G code. Not really.
Michael had
Go from
and Christian said it took
a horizontal cut. It's just one line,
Right.
but depends on how long the line is.
Right.
So by the G code line, you cannot tell.
maybe like something with the lid.
Yeah.
Or even a hole. A tiny hole is fine.
Like on the
It's
wood.
one line.
Right.
A big hole,
Just they have something.
these are the big hole. It's one line too.
Do we plan
One
on-
I and J.
So the timing.
You cannot tell.
Yeah.
That would take a lot of-
You will not be able to tell. So,
these swords were cut by
Yeah.
this machine.
say again?
If the
These
goal
swords
is
and this plate were cut by this one.
goal is
By you.
practice, then they
Yes.
should do it on wood.
That's right. That's right.
It's cheaper.
That's right.
It's much
So
cheaper.
we have a lot of machine cut pieces. Somebody probably just gonna have to put it here, up there, right? Sand it. Coach one can help me with this, right? The cut is gonna be really rough because this is not a.
What kind of is it? What grit is that? Is that just
That's the exact same one.
same one? Yeah. I think we have the
Exact same
exact
one?
same. We have the exact same one.
Okay.
Do you? So and when do you start use this?
I first have this.
Mm-hmm.
They do not like it because this is really really loud,
Oh.
and then they start using it,
Okay.
and they do not use that. And what else? What else I want to go through?